right, so thank you everybody for joining us this afternoon, this morning, I guess, on your part, and this evening on my part. So this is a series that the team in Hong Kong asked us to kind of put on around some of the directions that we're going with digital twins. And when we first started talking about this, we said, well, that's a really big topic, right? And it's a very big thing to talk about. So what we've decided to do is break this up into a small series and talk to you a little bit about specific aspects of building up towards a digital twin. So today we're going to kind of cover a foundation for digital twins, and we're going to focus in on reality capture. So do a quick introduction of the speakers today and who's going to be presenting. Myself, I'm Micah Callow. I'm the technology director for AEC. I support kind of the customer and the technology implementation in and around the area of AEC, which stands for Architecture, Engineering, and Construction. That also includes environmental consulting. And we very much focus on supporting those firms that deliver those things through consultancy, that are doing design work, they're doing construction work, doing a lot of asset management work. I'm joined by Nico. Nico, you want to introduce yourself?
Of course. Good morning, everyone. I'm Nico Bonifu. I'm based in San Diego, California, in the United States. I'm the product manager of Sitescan for ArcGIS and Esri's online drone software services.
Thanks, Nico.
Daniel.
Hi, everyone. Good morning. I'm a solution engineer on the AEC team for Esri, based out of Denver, Colorado. And I help support our customers with technical workflows and solutions to help meet your business needs with geospatial solutions.
Thanks, guys. So they'll come back a little bit later on and dive a little bit deeper into some of the technical aspects of what we're talking about today. So when we talk about building digital twins, and in especially the space that I work in, we look at it from the initial planning and thinking through the idea of a project all the way through to the owner operator. One of the things that we've seen traditionally in this kind of plan, design, build mode is that we see this kind of up and down undulation when we move from one phase of the project to the other. And it's where we're losing a lot of information and almost starting over in a lot of cases, and we're not necessarily handing it over, whether it's within an organization or whether it's within multiple organizations, which it often is when we're talking about building infrastructure or developing new buildings, building new highways, etc. But what we're working towards here and what our focus is to start to say, well, how can we use technology to start to try to smooth out that handover? So effectively move that from a thing that we have to start over on to something that's kind of a little bit smoothed out. And also maybe that starts to help us think about removing some of the silos that we see that naturally build up around this process, right? So where people are solely focused on what they do, which is what causes that dip. So that's where we're kind of focusing our attention and why we're talking about digital twins in the way we're talking about them. So I say digital twins, I think it's super, super important to define what is a digital twin, because I feel like there are as many definitions out there as there are letters in the alphabet. So at this point, digital twins, in what I'm referring to, is a virtual representation of the real world, right? And this includes physical objects, processes, relationships, and behaviors. So think sci-fi representation of something, right? A water network, a road and transportation network, buildings and their heating and air conditioning, or space occupancy management. These are all examples of digital twins. GIS creates digital twins of the built and natural world, and we're going to show you a little bit of that directly today. And it uniquely integrates many types of digital models. So what we try to say is that look, location is the ultimate joiner of information. And when you want to talk about representing the real world, location is the primary starting point. And that's what we're going to focus on today in a big way. Now, just as a reminder, GIS provides a process and a framework, right? So when we talk about building digital twins and using GIS in that context, we remind ourselves that GIS has been doing a lot of this for a very long time. Digital twin is just kind of the new introduction of an approach. In a lot of ways, digital twin is a strategy, not necessarily always a thing, right? So it's an aspiration. And GIS plays a role here because we do things like measure and do data management, and we visualize and we map that information so that we can analyze it and model it, plan and design the future, and start to make decisions. And that ultimately leads towards actions. And these are all things that are necessary when you talk about trying to build a digital twin of a city or of a utility network. We talk about the business drivers behind why we focus on digital twins and why our focus has really been amped up in this area is because we see the need, right? So there's a need to increase kind of operation and project portfolio efficiency and remove those silos I talked about a minute ago. And this allows you to use that saved revenue or recognized revenue in order to reinvest it or to aid in the development of new approaches, new business approaches, which is the foundation for digital transformation. So, but we also need to maximize our investment, right? So we need to maximize first and foremost the investment we make on people. If we're constantly shifting and technology is constantly moving around us and we're not bringing it to the end user experience, then we're having to constantly retrain our people, which is costing us a lot more than we recognize at the end of the day. And then it's about data and technology. So I stress that that people part is the first piece of this. This allows us to start to talk about solving physical issues faster and detecting problems sooner. It allows us to decrease the overall risk of the project itself and supports the decision making and a little bit more directly and a little bit in a more communicative way, which ultimately allows us to deliver projects that are more sustainable and scalable in the long run. So as I said before, GIS has played a role in the world of building digital twins for a very long time. So this is not new. We're introducing some concepts and some ideas around how we deliver this and what we deliver, but GIS has played a role for a very long time. Landscape models, for example, are landscape, environmental, natural world modeling at scale, right? So that's what we do really well with location, is kind of modeling the broader picture. BIM modeling is really becoming an important piece of this conversation because BIM, not a building, but to build something, the BIM process develops a lot of detailed structures that can aid in the development and increase of building digital twins, right? So we can get more detail and more context and more understanding by bringing in BIM models. And we can bring them together in GIS at scale, right? So we can start to understand them in context and in a broader sense. Network models the same way, utilities and pipelines and road highways. These are networked models at scale. And last but not least, we start to talk about cities, right? Like city digital twins at city scale for urban planning and space management and development support, etc. We start to think about city scale digital twins. And GIS has played a role in all of these for a very long time. So where we're going to focus today and kind of bring it back to what we're going to be doing is we start to talk about this in phases, right? So when we talk about building digital twins, first and foremost, we talk about data capture and integration, right? So first we have to have the information. We have to characterize what we're doing. We then need the ability to look at it, visualize it, make it understandable to an audience that's not necessarily a bunch of GIS professionals. So we see a lot of the advent of dashboards, and we're seeing the introduction of real-time information in this area too. And that really starts to differentiate things. And by doing that, we can start to analyze and predict what's not only what's happened, what's already occurred in that road network, and start to predict what's going to happen in the future based off of the information that we have. And then last but not least, we share and collaborate. So today, we're very much going to focus on item number one, right? Data capture and integration, specifically around reality capture and integrating that information to characterize a site. So before I move on into the actual meat of the demonstration here, I wanted to give a special thanks to the Taiwan Fisheries Agency and IDT, our distributor in Taiwan. They really stepped up to help us with this demo, which really I think will bring to life what we're going to show you. And it was really a great exercise, especially working across the world together. I think that was really a really special experience for us. So we want to thank you guys for helping us on this. So setting the stage for our project that we're going to run through this kind of technical workshop demo from is that we're in Taiwan and we're looking at the northern part of the island. Bao'zhui, I'm going to say it wrong continuously. Bao'zhui Fishing Port is an area that we're studying. We've got a need here, a fictional need, but nonetheless, we're looking at the port, and we kind of have some ideas around some design and some new development that we want to do. And we also want to look at kind of the intersection of kind of the built and natural world. So obviously being on a port, we're always concerned with water, right? And we've got a need to service our citizens. In this case, they're building a government building on one of the piers. And so we wanted to start the project really early on by capturing a lot of really good information that will allow us to characterize this site and to really aid in the project as we move forward. So that's what we're going to dive deep into today. And I'm going to have Nico start us off on that.
Well, good morning again, everyone. Thanks for being on here. So, so to start digitizing this Bao'zhui port, we really started off with no data at all. So for this project, we decided to start by capturing the entire port using Esri's Sitescan for ArcGIS. Sitescan is Esri's end-to-end drone solution to capture, process, manage, and render a site in 2D and 3D and feed that content into your GIS. Through standard drone, low-cost drone, you're able to capture photos automatically and process this data on the cloud to generate both 2D and 3D outputs. So very high resolution orthomosaics to use as your base maps, 3D point clouds and meshes, which we'll see today as part of our digital twin, digital elevation models, as well as 360-degree photos, and for specific applications, thermal orthomosaics, or even geo-referenced videos, which we call full motion video or oriented imagery. The Sitescan workflow can be broken down in 3 steps. First, we'll start by planning and capturing our data, and that will be done using the Sitescan iPad flight application, which supports a variety of drones. Once the images are captured, they'll be uploaded to the Sitescan Manager cloud for processing. This is where users can perform first phase analysis on the data and then publish that data into their ArcGIS system for advanced analysis and integration with other data components to really start creating a true digital twin. And for those of you who work in a CAD environment, there's also integrations with Autodesk that also connects with your broader GIS system. So starting with the flight application, we worked with the teams in Taiwan of the Taiwan Fisheries Agency and IDT to plan flights together. So because the flight application is cloud connected, we were able to plan a flight from California and share it with the teams in Taiwan to go and execute. The flight app offers a variety of different flight templates, which you can see as different icons on the screen here, whether you're trying to map large areas, whether you're trying to scan a 3D structure like a building, mapping roads, or if you're doing manual inspection flights. And the flight app also handles your fleet management and pre-flight checklist. That means that it automatically keeps track of who's flying a drone, what drone, where, with what battery, so that when you have a large drone program and a large organization, all that information is handled automatically. When it comes to flight planning, Sitescan is quite unique because it has some functionalities that are only possible for a product that's part of the ArcGIS system, like the ability to bring in 2D and 3D content from the living atlas of the world or from your own GIS database. It has the ability to follow terrain. It has these capabilities of planning flights in 3D, which I'll show you in a quick moment. So when we started planning this flight with the teams in Taiwan, we first had to define an area where we needed to map. And so our work had actually started in GIS, in ArcGIS Pro, by simply tracing a boundary. And that boundary can be brought into Sitescan as an overlay. So through our overlay menu, we were displaying our KML file in this case, and also displayed the location of our ground control points, our survey points that will help improve the accuracy of the site. And from there, we simply trace out the area that we need to map. And so we decided to go a little wider than our area of interest to make sure that we captured all our ground control points. At the bottom of the screen, we can see that right now the flight time estimate is 59 minutes. That would have a 0.7 inch resolution, which is about 1.5 inches. That it would take 340, well, now 340 images now that we changed the altitude. So we raised the altitude to reduce the flight time. And now we'll have a resolution of about 2.5 centimeters. We made some small optimization to adjust the flight path. And then we can view it in 3D as well to see what the data capture will look like and where the photos will be taken. And really, for to update a base map, that's really all there is to it. It's that simple. So from there, all we had to do is save the flight plan, and then it's automatically shared with all the users within that Sitescan project. We'll jump ahead here a quick moment, stay in the flight app, but let's say we've already captured data of the site, and we need more. We need more information to optimize our digital twin. Well, now that we've already flown the site, our base maps are automatically updated in the app without the need to connect to ArcGIS at this point. We can see our updated base map in the background. And maybe we've decided that we need to map this road that leads to the port because we did not do that the first time. So here we're using the corridor scan flight mode. The challenge here is that this road is on a very steep hillside, but thanks to Sitescan's terrain follow, the app will automatically plan a flight that will follow the ground at a constant height. This means that you'll have a safe flight, but you'll also have constant image resolution and constant overlap between your images, which will in turn produce better results. We're also able to load other 3D content, in this case a 3D mesh, but it could be utilities data, property parcel data, anything that you have in your GIS environment can be loaded in the flight app to assist with the flight planning. So now let's take a look at the actual data capture from the teams in Taiwan. So they came out in the field and opened up their Baduza port project and loaded the flight plan. On that day, they were flying a Phantom 4 Pro V2 and simply reviewed the flight setting just as a precaution, then would complete their pre-flight checklist. So this checklist is fully customizable to meet the needs of your organization and your government agencies. Then go through automatic system checks on the drone. And once that's done, the pilot will just need to swipe to take off. At this point, the mission is being sent to the drone and the flight is fully automatic. The pilot is just monitoring the flight. In the upper right of the screen, we can see the video feed from the drone taking off over the port. And now we'll switch to video. We'll accelerate the video a little bit. So if you have motion sickness, you might want to look away for a couple seconds. So the drone's going to start the mission, and there it is. Now it's capturing photos, hundreds of photos that will help us render a detailed 2D and 3D model of the port. The pilot can monitor some key information about the flight, distance from home, altitude, and then once the flight is complete, the drone automatically returns to its takeoff point. There, this flight was about 25 minutes in total. So once the mission is complete, and we've captured our data using the Sitescan Flight app, we'll need to upload that data to the cloud for processing. That can be done in a few ways. You can transfer the images to the iPad wirelessly in the field, or we can transfer them to the iPad with an SD card reader. What's great about both these options is that it allows pilots in the field to do quality control of the images. They can review the quality of the photos, but also proper overlap between the images, which is very important for producing high quality outputs. And the third option is going through your computer, which works fine as well. It's a little more manual of a process. And this is also the way you would use it if you captured data using a different application than the Sitescan Flight app, which is perfectly fine. In all cases, your data gets uploaded straight to the Sitescan Manager cloud. And the fleet management data will also sync with Sitescan Fleet Management as soon as your iPad connects to the internet. So that will send information about the drone, the battery, or the batteries, the pilot, as well as the responses to any checklists that were completed. So while our data is processing on the cloud, I'll talk to you a little bit about Sitescan Manager. This is a web application, so anybody can access this from their web browser without installing any software. And it provides some analysis capabilities and some collaboration tools, and most importantly, the ability to push that data into your GIS. It includes unlimited cloud processing of your drone imagery, as well as unlimited storage of your drone data. And we provide secure cloud hosting, currently either in the United States or in the European Union. There's a lot of tools that are really intended for your less technical users. So people maybe are not GIS experts. And we try to give them the ability to make use of this data without having to download massive files or have any software installed. They can perform linear measurements, volumetric analysis, generate reports, and share the data through some links that can be emailed and don't require any login credentials. And what's also very important in a lot of cases when we're creating a digital twin, especially when we're integrating different pieces of data from different sources, is producing high accuracy data. And for that, we offer different ways to improve and verify the accuracy of the data produced by Sitescan. So through the use of ground control points, which are targets that are on the ground surveyed, it can be visually identifiable points. That's what we used at Badouze, or actual targets, checkerboard targets, as you can see in the image on the left. We'll associate those to the photos to help increase the accuracy of the results. And Sitescan has the ability to detect those automatically through computer vision and offers workflows to do it manually. We also have functionality to generate a report that will provide information about the processing and the accuracy of the results. And for those of you who use drones with high accuracy GPS, known as RTK or PPK, Sitescan can make use of that information to produce higher accuracy outputs. So we just got an email that our results were done processing. In practice, this flight took about 7 hours to process. It was 1,250 photos. And so I would get that email. Any other member of the project who requested notifications would also be notified that there's new data in our Sitescan project. So let's take a look at that. So here I'm just on my web browser on Google Chrome on sitescan.arcgis.com in IDT Sitescan organization. There you go. We'll see, so we see that we have only one project that I'm a member of in this organization, and it happens to be our Badouze port in Taiwan. So I can click here, and this will bring me to our results. So immediately we're brought to this 2D view display of the orthomosaic overlaid on top of Esri's satellite base maps. And so this flight, we can see here the 1,200 photos, 1,250 photos that were used to generate our orthomosaic, our mesh, and our point cloud. And you'll see that this is a very high resolution base map. And actually, if you download this, you'll see when Daniel brings this into Pro, it's even higher resolution when you bring it in locally. So we have this orthomosaic viewer that's accessible to anyone. We can view our photos. We have the ability to make markups. So if there's an area we want to identify and communicate that maybe shouldn't be accessed, that can all be done from here very easily. We have the ability to display elevation data in different ways through an elevation heat map, or generate contours directly on the web. So I'll take a moment with all the water here. There we go. So you can generate contours at any interval you'd like and export those as shape files. We also have the ability to view data in 3D. So we can jump to our point cloud viewer. What's nice about the point cloud viewer as compared to the mesh, it's less pretty to look at, but it doesn't interpolate any information. So it's very accurate data. And this point cloud gives us several tools. So this is just a preview of the full point cloud, limited to 10 million points. And this point cloud is over 100 million. So we're looking at 1/10 of the resolution here. But we have some tools that allow us to do quick measurements directly on the web, like measuring a height. Another tool that's really interesting is the photo inspection tool. So if you want to look at a specific area, you see that something's looking a little strange about this building. The photo inspection tool will pull up all the photos that show a specific point and allow us to go look in to see if there's any damage, for example. And so it looks like there may be some damage to this roof here. So that's something that could be marked up, saved, and generated as a report for future use. And lastly, I will show you our mesh. And here I'm showing you something that's not released yet in Sitescan. Will come out during our big user conference in July. And this is the new Sure Mesh Engine processing. And we're viewing this in a new viewer, in the scene viewer. And this is a very high fidelity mesh. This was done with just nadir imagery, so photos captured straight down. And it's a huge enhancement to what was available up to today in Sitescan in terms of mesh production. We can see very high detail, very high resolution textures. And this is going to be a key part of creating our digital twin for this project. And before I share this data with Daniel, show you just a couple of the tools that are available in our 2D view. So looking around our site, we saw this beautiful boat. Close to it, had identified that we had an area where we had maybe some debris that we'd like and trash that we'd like to haul away. So a tool that's available here is the volume tool. And that allows us to just click around very simply. And we'll get a volume immediately, and you can even go in a 3D view to then visualize what you've just scanned. And so here we have about 169 cubic meters of trash. So probably about 10, 15 trucks would be needed to remove that. So it's actually a good amount of debris that we need to take away. But we'll let Daniel here focus on our new buildings and redevelopment of the port. So rather than exporting the data locally, which can take some time because these files are so big, what I'll do is simply publish to ArcGIS Online. or ArcGIS Enterprise. And I'll choose who I name my project. I'll choose a folder. So maybe I'll create a new one here, call that Baluza. I'll choose the team members I want to share this with. So let's do our engineering teams today and our GIS and BIM team. I could add tags or a description and choose the outputs I want to share, and then I'll simply publish. And so in a few moments, Daniel will have this data available in ArcGIS, and we'll be able to take over from here and create a true digital twin. So Daniel, I'll pass it back to you.
Thank you, Nico. And while Daniel set up for his presentation, we have 2 questions. Do you mind just answering them here?
Sure, go ahead, Zoe.
The first one is, what happens if our drone lost connection during the flight?
So you have 2 options. So the default behavior is that the drone will come back automatically as soon as it loses connection. If your country allows your drone to fly without connection, there's an option in Sitescan that allows you to continue the mission, call it continue without link. And so the drone will keep flying the mission, and when it gets low on battery, it will come back and land by itself.
Cool. The second question is there any option for drone to stay stationary and capture full motion video from the same area?
Yes, absolutely. So you can record video in any of the flight modes in Sitescan. If you want to stay stationary, you would use the manual inspection flight mode. You can still do an automatic takeoff and tell the drone go to this altitude and hover. And you would place the camera and then record video. Anytime you record video, either in manual flight or automatic flight, what we call a geospatial video log is created. And then you would take that log from the Sitescan flight app, take the video from the SD card, and take that into ArcGIS Pro with full motion video to do your, use the multiplexer tool there to then make use of your full motion video.
Sounds good. So I'll pass on to Daniel.
All right. Thanks, Nico. That was a great presentation of Sitescan. Thanks a lot. Once again, thanks, Nico, for setting that up and talking a little bit about how the data capture process works with Sitescan and the abilities of Sitescan and being able to share with the ArcGIS system. So here we are in ArcGIS Pro, and this is where product integration becomes an essential component of our workflow to create a digital representation in our first steps of creating a digital twin. From sharing reality capture data from Sitescan to ArcGIS Online, we connect ArcGIS Pro to the same ArcGIS Online, to our ArcGIS Online organization and retrieve that data and begin to work with it. So over here in our catalog, typically we work in folders. These can be network drives, these can be local connections. However, with the advancements of ArcGIS Pro, we can now also connect to BIM Autodesk Construction Cloud. And we can view some of the Revit files we have for the Bateau support. And also, now that Nico shared this data to ArcGIS Online, we can actually jump into our group where all this data has been shared, and you can see exactly all the different features that we shared straight from Sitescan to ArcGIS Online that I can now bring directly into Pro. So let's go ahead and we'll add in our mesh and we'll get started. So here in Pro, we have our mesh, and what we can see is actually a little bit distracting with the water. The way the data is captured, the water can be a little bit noisy. It's one of the hardest things to capture in the reality capture process. Now, fortunately, ArcGIS Pro has some nice capabilities and new added capabilities, starting with ArcGIS Pro 2.7 and I'm here using our latest release of ArcGIS Pro 2.8. And we'll show off some of those mesh editing capabilities. So for example, we have our water. And I like to look at it directly from above, just as our drone did. Now we can clip manually by drawing with our mouse in Pro, or we can be a little bit more accurate with it. And actually, I have created a feature class of the water area that we intend to clip today. And this will be our input in the mesh editing process. And that looks like this. We simply see our integrated mesh layer functions, and we'll add a new modification. And in this case, we'll import from an existing polygon feature layer, that being our water feature. And we have 3 operations. We'll be using clip for this function. We'll be, mask is for essentially isolating an area of your mesh, such as a building or any feature that you'd like to isolate and highlight on your mesh. And then we have replace, which is a little bit, it's basically just flattening the mesh. So where we have existing buildings and where we have BIM data for those buildings, we'll actually be flattening that. So first we'll clip the water out. It's a fairly quick process. We turn off our water. We can see that we've now clipped all the water from the mesh. So this can be a less distracting representation of the port. And now over here, we can see that we have existing structures in place. And I'm just going to quickly highlight where we have BIM data. If I turn it on, you'll actually see it. It should start to actually shoot out from the mesh. So these are areas that we actually need to flatten in our mesh before we publish online. That way we can view our BIM data unobstructed. So we'll do that with another mesh editing process. So we'll highlight our mesh, and then we'll use replace. So up here is the fish market, and we're simply just drawing a polygon around it. And also we'll clip out where we have a government building over here. And we also have another building here. And you don't have to be very accurate. It's just a simple few clicks. And if we explore the map, we can see exactly what we just did. So we flatten this building here where we have a bike shop. We flatten this area with our fish market. And we left a little bit over there, but that's okay. For our government building, we'll turn on our BIM data. And once again, we brought in these Revit models directly through BIM Autodesk Construction Cloud connection directly in ArcGIS Pro. And then with a few small functions, we were able to create scene layers that we are displaying over here. So let's go ahead and we'll have this published to ArcGIS Online, and we'll jump in there next. So ArcGIS Online, we manage data through groups and folders, and we specify specific members to have access to these data sets, as well as applications, maps, and any other item that we have in our group. So you can see just how much data we have in here, mostly from our Sitescan process. So the reality capture process captured a lot of information. So in a way to combine that information together, all the reality capture data, the mesh that we edited, we can bring that all into a web scene. And what we're looking at here is actually the mesh before we edited it. So you can actually see exactly how it looked in Sitescan. And then a quick edit in ArcGIS Pro, as we saw earlier, we now have our edited mesh, and we can start to bring in contextual data around it to give this a true representation of the built and natural environment around it. So we have our integrated mesh, and we actually have a national data set of multi-patch buildings for Taiwan, just to give it some more context for the area around the port that we didn't fly. Now we can turn off that data set, and as we just saw in Pro, we can view our Revit models as well as a nice animation of the ocean water. So we can see everything in here from our integrated mesh to our Revit data, and we can also view the point cloud data as well. Here we have colorized point cloud, giving it the same representation we saw in Sitescan. Here we have a classified point cloud, also from Sitescan. The classification of this point cloud data actually occurs in the scene viewer, how we specify how it's classified. So we have the natural ground, we have vegetation, and we have buildings, but we can also display elevation. And what this actually gives us access to is being able to visualize a common port scenario. Ports are very vulnerable to the environmental impact of sea level rise. So a simple point cloud showing elevation can show us what is going to be more vulnerable at the lower elevations versus the lesser vulnerable elevations of the built structures, the roofs, and so forth. And we can quickly identify that through the scene viewer. So let's go back to our first steps of our digital twin representation. We have our BIM data, we have our integrated mesh from Sitescan, we have our ocean layer, but let's also look at the sea level rise in itself. So here we have at base layer of what it is currently today. And if we rise it by 2 meters, hasn't really affected much yet. Now, if we raise it to 3 meters, we can start to see over here the water is actually rising up closer to the ground. If we go back to that first one, you can see it hasn't quite hit the land yet, but now that we're at 3 meters, it's starting to get very close to the structures on the port. And at 4 meters, we actually see it affect the port. So this digital twin representation at its early steps is already giving us a great representation of how the natural environment affects the built environment. And actually, we can zoom in a little closer to one of our BIM models and see how this structure was actually designed to account for a sea level rise. And we can do that through various tools that our scene viewer application comes with straight out of the box through ArcGIS Online. No coding necessary. We have a daylight tool, which can actually show you different daylights, such as this. But we'll turn off the shadows for now, because what we'd really like to look at is the building slicing tool. So we can slice through this building and we can start to see how it was actually designed with sea level rise in mind. We'll give it just a quick second here. And you can see this is fully dynamic on our scene viewer application. And we can see at the 4 meter sea level rise, it's actually not in the building yet. It's actually below the building, because this building has actually been designed to account for this sea level rise. And we can measure that. We can measure just how much sea level rise this building has been accounted for. So if we're already at 4 meters, then above 5 meters, we might start to see some water actually get into the building itself. So this is really great information that we can feed to our stakeholders and anybody who is an audience of this project, or maybe we have the builders, the construction crew, and the architects, all wanting to see how this operates. So to create a more engaging piece to share with our stakeholders, we're going to use what we have called Hub. Now, Hub is an engagement platform that is formed around projects, issues, initiatives, and it brings together data in ArcGIS applications to create a more efficient digital deliverable mechanism that engages the project audience through a story-like structure with engaging content, such as a project overview, maybe goals. In this case, our workshop series, our next steps in the digital twin creation process. We can also add in maps. So this is a web map of the fishing port, fully dynamic, And in fact, when we zoom in closer, our site scan orthomosaic starts to show up. And once again, you don't need to download any additional software. This can be consumed through mobile and desktop devices, just straight through a browser. So we can tell a little bit more about the digital twin process, what ports, why ports are necessary for creating digital twins. We can include our scene that we were looking at earlier. We can view the actual flight video from the drone, and we can link other applications and even upcoming events, such as this workshop itself. So now that we've gone through the digital twin creation process, I'd like to pass it back to Micah.
Thanks, Daniel. So I'm going to share my screen again. All right. Thanks, Daniel. That is really interesting. And I love that you're kind of showing us finishing the story, right? So not just gathering the information, but which is a really important part of this overarching story that we're talking about today and getting this project started. But we also talk about finishing. It's that sharing and collaborating, which is so important. So just to reiterate, we really focused today in our session on kind of the steps around data capture and characterization, right? And then we did touch a little bit on real-time visualization, a little bit kind of on analyzing and looking at some different things to show you that the value of that data beyond just the simple physical representation of the natural environment and the built environment. And then we talked, as Daniel showed you guys at the very end there, sharing and collaborating. It's kind of like finishing the race, right? Crossing the finish line and being able to share that in a way that's meaningful to the end users. So I really want to thank you all for spending some time with us this morning. We're really excited about this, and we're really excited to kind of show off how some of the Esri technology and how location and GIS really plays an important role in building up the concept of digital twins. Right? There's a lot of different opportunities, a lot of different activities that we can do. And we hope that this gets you to start thinking about some of the things that you could start to do using some of our tools from Esri. So thank you very much for coming today.